Hello everyone, welcome. I think we have feedback. I'll just try and work this thing out. Just give me a second, please. Okay, I think we still have the same challenge. Okay, I will work on this in the coming 2 minutes, so please bear with me. Okay. Maybe we can try and see if this works. One, two. One, two. One, two. I think it's better now. Okay, all right. So welcome to today's session on Yebo Tutor. So today we'll be doing physics for this session, and we'll be looking at forces, momentum, and energy and power. So this is what we'll be looking at today. So I hope you guys are not experiencing a lot of feedback from this end. So we'll just try and work with this for today. Right, so we have a question, that's a question on the screen. So I'll just shift it so that we start from the one before it. Okay, so this is where we are going to start today. Initially, a girl on roller skates is at rest on a smooth horizontal pavement. The girl throws a parcel of 8 kgs horizontally to the right at a speed of 4 meters per second. Immediately after the parcel has been thrown, the girl roller skate combination moves at a speed of 0.6 meters per second. Ignore the effects of friction and rotation. So this is the question given. The description is of a girl carrying a parcel which she throws to the right, and the parcel has mass 8 kgs. And when it's thrown to the right, its speed is 4 meters per second. So it has a velocity of 4 meters per second to the right. Then we are told that the combination of the roller skate and the girl moves at a speed of 0.6 meters per second. So the first question is, define the term momentum in words. Define the term momentum in words. So if any one of you can do that for us, we would appreciate. How do we define momentum? How do we define momentum? Please confirm if you can hear me. If the audio is coming through to you, please just type something on the chat box. Anyone to confirm? Through to you, please just type something on the. Yeah, that means we should be good now. I think we have a proper sound production from this end. So the definition of momentum. How do we define momentum? So the momentum of an object of mass m is the product of its mass and its velocity. So it's the product of the mass and its velocity. The momentum of an object is the product of the object's mass and its velocity. So that product of mass and velocity is what we call momentum. So we'll move on to the next question. So the next question, which is part 4.2. Okay. Will the girl roller skate combination move to the right or to the left after the parcel is thrown? Name the law in physics that can be used to explain your choice of direction. So we have the girl and the parcel, mass 8 kgs. Is it? Yes, 8 kgs and 4 meters per second. Okay. So the question again, will the girl roller skate combination move to the right or to the left after the parcel is thrown? And name the law in physics that can be used to explain your choice of direction. So what is happening here is the girl holds a parcel, which is this block, 8 kgs, and throws it to the right. Throws it to the right. When it's thrown to the right, it means initially it had 0 velocity, it was at rest, but then it's given a momentum, which is a product of its mass, 8 kgs, and the velocity to the right. Now the question is, the girl who is on roller skates, will she also move to the right or to the left? So the principle of conservation of momentum will tell you that the total momentum is equal to the the total momentum of a system is equal to 0, or the total initial momentum is equal to the total final momentum in a closed system. So that's a system in which we don't have any external force or any net force. So for this system, which is the girl and the parcel, when momentum is given on an object to the right, then to balance with that, if the total initial momentum is to be the same as the total final, then which means the girl should move in the opposite direction. So the direction is to the left. This is to counterbalance and in this case, satisfy the principle of conservation of momentum. So the law which is applying in this case is Newton's third law, because there is a force that is exerted on the object which begins to move to the right, or which is thrown and moves to the right at 4 meters per second. And that force is equal and opposite to the force that should push the girl in the opposite direction. So that is explained in terms of the momentum, and that's also a consequence of the third law, Newton's third law. So the girl and the roller skates will move to the left, and this is explained by Newton's third law. It's the third law. Okay, so far so good. Oh, sorry about that, guys. I tend to forget about this screen. Okay. Thank you, Viscolite. Thank you for notifying us about the screen. So it's great that you are following. So we were talking about the girl on roller skates and the parcel being thrown to the right, and the parcel is given a momentum which, according to the principle of conservation of momentum, should be the same momentum with which the girl moves to the left. So this is a consequence of Newton's third law, which is what we can use to explain what's happening here. So the action and reaction are equal and opposite. Or if body A, which is the girl, exerts a force on body B, in this case our parcel, then body B exerts an equal but opposite force on body A. So that's simply put, action and reaction are equal and opposite. Right, so let's see the next part. The next question is 4.3. Calculate the mass of the girl. So given that the total mass of the roller skates is 2 kgs, what will be the mass of the girl? So that's a 5-mark question if you are able to see that. So how would we calculate the mass of the girl? How would we calculate the mass of the girl? This is the given situation. a girl throws an 8 kg parcel to the right, and the parcel moves at 4 meters per second. Then we've agreed that the girl on roller skates will move to the left, and we're told the mass of the roller skates is 2 kgs. We need to find the mass of the girl. So the mass of parcel, we'll call it MP, 8 kgs. The velocity of the parcel is 4 meters per second. We'll give it a plus. The positive is for the right, for the direction to the right. So which means negative for the direction to the left. Then we have the mass of the skates, 2 kg, and we need to find the mass of the girl. I think we are given some extra piece of information again there. Let's see. So the girl roller skate combination moves at a speed of 0.6 meters per second. So we ignore friction and rotation. Then we're given V of the girl and roller skates. So this is a person will not do for P. Okay, let's just give it a subscript L, right? So the roller skate and the girl will both move at the same speed VL, which is 0.6 meters per second with a negative because it's to the left. So this one we'll call minus 0.6 meters per second. So this is all the given information, and with this we should be able to find the mass. So I was just putting together the information. I'm gonna remove this. So the information that we've got, that the mass of the parcel is 8 kgs, the velocity is 4 meters per second to the right, so we've assigned the positive sign for directions to the right. The mass of the roller skates, we're told, is 2 kg. The mass of the girl, we need to find that. And the velocity of the girl on roller skates, and the roller skates, is 0.6 meters per second to the left. And we said the direction to the left is negative. So that's minus 0.6 meters per second. Now, how do we find the mass of the girl? So we can use conservation. Of linear momentum. Which is total momentum before equals to total momentum after. So in other words, total initial momentum equals to the total final momentum. Okay, so the initial momentum is the mass of the parcel times the velocity of the parcel plus the mass of the girl plus the mass of the roller skates times the velocity of the girl and roller skates. This should be equal to the mass of the parcel after it's thrown times the, okay, so I think we need the initial and the final there. So velocity initial times the velocity of the parcel final plus mass of girl and mass of the roller skates times the velocity of the two final. So the mass of the parcel 8, velocity 4 plus the mass of the girl. Sorry, initially the velocity there is 0 when the girl is still holding the parcel. The mass of the girl and mass of the roller skates times the initial velocity of the girl and roller skates, which is 0, should be equal to the mass of the parcel 8 kgs times the velocity plus the mass of the girl plus 2 the mass of the roller skates times the velocity, which is negative 0.6. So everything multiplied by 0 is 0 equals to 32 minus mass of girl times 0.6 and minus 2 times 0.6. So mass of girl times 0.6, by taking that part to the left side of the expression, will be equal to 32 minus 1.2. So I think you can calculate this. I think you can calculate that. 32 minus 1.2 should be 30.8. So the mass of our sister there is 51.33 kgs. So it's 51.33 kilograms. This is the mass of the girl. So we have used conservation of momentum to find the mass of the girl. So the initial momentum, knowing that velocity initially was 0, is simply equal to 0. The total initial momentum of this system is 0, and the total final momentum should also be equal to 0. So which means the velocity times the mass of the parcel should be equal and opposite to the momentum of the girl and the roller skates. That's how we get the mass of the girl. So in other words, the total change in momentum of a closed system is equal to 0. Now, let's move to the next thing. So in the next part of this question, you are required to calculate the magnitude of the impulse that the girl roller skate combination is experiencing while the parcel is being thrown. Calculate the magnitude of the impulse Calculate the magnitude of the impulse that the girl roller skate combination is experiencing while the parcel is being thrown. Take note, the key word there is magnitude. Magnitude. So impulse, what is impulse? What is this quantity we call impulse? So simply put, impulse is the change in momentum. Which is momentum final minus momentum initial equals to delta momentum. So this change in momentum can be m delta v. It is what we call impulse. And this is also equal to the product of the force acting in this setup or acting in this system times the time of action. That's during a collision, usually the collision force times the time of impact. So we call that impulse. It is the time effect of a force. So in this case, where there's no impact, we just have a case whereby the lady or the girl throws the parcel to the right, and because of momentum conservation, the force on the girl by Newton's third law makes the girl move to the left with a certain velocity. So now the change in momentum is simply the final momentum minus initial momentum. That's the impulse. So what is the momentum, final momentum of the girl and the roller skate? Is mass of the girl plus mass of the roller skates times the velocity, which we said is negative 0.6, minus mass of the parcel, which is 8. Okay. Let me do this formula first. V L minus M parcel V parcel. No, it's actually minus M girl plus M roller skates times zero. That's the initial velocity. So that's VL final. This is VL initial. So we'll call momentum impulse or change in momentum delta P. We use a letter P for momentum. Where did we define momentum here? You can use P. So this is the impulse. It therefore follows that, oh, I forget about the question. Sorry, guys. So this is, we have said that our momentum is letter P, and impulse will be delta P for change in momentum. So the final momentum minus initial momentum is the change in the momentum given by the product of F and T. So in a case or situation where we are dealing with collisions, the collision force and the time of impact are the two quantities that give us a product we call impulse. So other than defining impulse as the change in momentum, we can also call it the time effect of a force. Now from the expression given here, we are substituting for the masses and the velocities. The total final momentum is the total mass of the girl and the roller skates times the final velocity minus the total mass of the girl and the roller skates times the initial velocity. That should give us the impulse. So this mass, we found the mass of the girl to be 51.3. So we plug that in, 51.33 plus 2, all this is in kgs, multiplied by the velocity of the girl and the roller skates at the end or after throwing the parcel is negative 0.6 meters per second minus the mass is the same, 51.33 plus 2 kgs, but this is multiplied by 0, the initial, and that should give us the change in momentum. So this is 0, and that will give us 53.33 times 0.6. kgs meters per second, or Newton per second. Is it Newton second? So you can calculate that and tell us what you get. .32 Newton second is the, so that's negative, is the change in momentum. So for magnitude, the answer is 32 Newton second as the magnitude of the change in momentum. So that's how we find impulse. That's how we find the impulse. Without any further calculation, write down the change in momentum experienced by the parcel while it is being thrown. The change in momentum experienced by the parcel is the same as the change in momentum experienced by the girl roller skate combination. So without calculating, that change in momentum is the same as the impulse, and it will be 32 Newton second. The change in the momentum is the same. The change in the momentum is the same for the girl girl roller skate combination and for the parcel. Okay, so I think we have done justice to that question. We've done justice to that question. If there be any questions, please feel free. We are here to assist you. So just write or type in your questions from the channel chat section, and we can be able to view them and respond. Otherwise, I think we can proceed. We can proceed to the next question. So this is a different question. We are done with the momentum part. The diagram below, not drawn to scale, shows a vehicle with a mass of 1000 kgs starting from rest at point A at the bottom of a rough incline. Point B is 200 meters vertically above the horizontal. The total work done by force F that moves the vehicle from point A to point B in 90 seconds is 4.80 times 10 to the 6 joules. Define the term non-conservative force. Define the term non-conservative force. So when do we say a force is non-conservative? So we have two things to define here. The first case is if the net work done by the force, or just if the work done by the force is dependent on or upon the path taken. So there is a case where the work done by the force does not depend upon the path taken. So if it is dependent upon the path taken, we can just say depends on the path taken. So this is the work done by the force in moving an object between 2 points. If that work done depends on the path taken, then the force is non-conservative. Or in other words, we can say if the work done in moving an object around a closed path is non-zero. So if the work done in moving an object round a closed path is non-zero, then that force is non-conservative. So that's a non-conservative force. Is force F a conservative force? Choose from yes or no. So how do we tell if the force F is conservative or not? So in other words, does the work done by that force depend on the path taken? What would you say? Any suggestions? Is the force F a conservative force? What would you say, yes or no? That's a simple question for a simple yes or no and a mark. So conservative or non-conservative? So in this case, this force is not a conservative force. This force is non-conservative. So the answer is no. F is not conservative, so our answer is no. In other words, the work done by F will depend on the path taken. Calculate the average power generated by force F. The average power generated by force F. So we are given the total work done, 4.80 10 to the 6, and the time it takes to do that work. So average power that will be the work done over the time taken. So in joules per second, which is the watt. So that's 53.3 kilowatts. That's 53.3 kilowatts. So you can also follow and do the calculation yourself and see what it is that we have done. So this is work done over time. That's a simple relationship for the power. Total work done over time. Now, next question. The speed of the vehicle when it reaches point B is 25 meters per second. State the work energy theorem. The work energy theorem. So can you recall? Can you recall the work energy theorem? What does it state? State the work energy theorem. So it's about the network done. Network or total work done on an object is equal to the change in its kinetic energy. So that's the work energy theorem for you. So the work done on an object, the total work done on an object is used to change an object's kinetic energy. So use energy principles to calculate the total work done on the vehicle by the frictional forces. The total work done on the vehicle by the frictional forces. So in this case, we want the work done by friction. How do we do that? The work done on the vehicle by the frictional forces. So we can apply the work energy theorem in this case and create an expression or equation from which we can use to find the work done by friction. So what we are given is the velocity at point B, which gives us the kinetic energy. So this gives us the ability to find the kinetic energy at point B. Then we have the mass of the vehicle, the height between the level of point A and the level of point B. We also have the work done by the frictional force in moving the car from point A to point B. So the total work done there is given 4.8 10 to the 6. So we'll say total work done and plus the work done by friction plus the work done in this case in moving from point A to point B, basically again the network done against the weight of the object. So we can call that WG or WW, the work done on the mass in lifting it up to a height 200 meters should be equal to delta kinetic energy. So this work done is 4.8 times 10. Okay. So this is the equation. Total work done, WT, 4.8 10 to the 6, plus the work done by friction and the work done against the weight in lifting the weight will be equal to the change in kinetic energy. So this is 4.8 10 to the 6 plus work done by friction, and the work done by gravity will be mg delta x cos theta equals to half mv squared. So are we given anything about the initial starting from rest? So it's starting from rest. So this is half mv final minus v initial squared. Okay, the change in kinetic energy. The work done by friction plus mass 1500 g 9.8. The height or the distance upon which gravity acts is 200, and the angle there is cos 180 because gravity is acting in the direction opposite to the height of 200 meters. So as the object is lifted upwards, the upward direction is the positive one, in other words. So the angle, the gravity, acts to the direction in which the displacement is considered is 180 degrees. Then this is equal to half 1,500 times 25 squared minus 0 squared. So 1,500 times 9.8 times 200 cos 180. That's minus 2,9,400. 4.8 times 10 to the 6 minus 2.94 10 to the 6 plus the work done by friction equals half times 1,500 times 25 squared 4.6 0.469 times 10 to the 6. So from that, you can find the work done by friction on the car. Fiscal light, did you say anything? We could have missed what you were saying from the chat box. So let's put the figures together. 4.8 10 to the 6 minus 2.94 10 to the 6 that's 1.86. So subtracting that from 0.469, ten to the 6, that's 1.39 times 10 to the 6 joules. That's the work done by friction on the car. This will be the work done by friction on the car. So in case my screen was obstructed, we have the work done, total work done, given in the question. And this, for us to find the net work done, we add the work done by the friction and the work done by gravity. And this is equal to the change in kinetic energy. So for gravity, it's simply mg delta x cos theta. If the direction of gravity and the direction of displacement of the object are the same, theta is 0. If they are opposite, theta is 180. So this is the case that brings in a negative sign for the work done by gravity. And we also get a negative there after taking this to the right hand side. So the work done by friction is minus 1,39 times 10 to the 6 joules. Okay, so this is how we work on momentum, energy, and power. I hope you guys had a good time. And if you would have any questions relating to what we've done, that's for those who are going to be seeing this video a bit later. Please feel free to get in touch with us. So from me and the Yebo Tutor team here at the studio, have a pleasant evening and all the best with your studies. Bye-bye.